So we built this application in our last recording where we have a student controller and has create student, has get students, and this controller class will basically have this student repository injected. And what Spring does in the background is it auto-generates all the queries and allows you to avoid having to write any boilerplate code. This is acceptable for your project purpose. Like if you want to just like use this kind of method to create all your controllers and do whatever you need to do, that's fine. I think that there's no reason why you shouldn't do that. But as you develop your application further, you'll also face issues with the scale. And what I mean by that is the more methods you write, the more things you include, you'll naturally see that some kind of responsibility belongs to certain layers, and you don't want to be polluting each controller method with too many lines of code. Like your controller should ideally be as lightweight as possible. So in Spring Boot, I guess, and also in general, we enforce layers based on like what it contain, what each class contains. So usually at the very top level, we have a class usually named, some controller like student controller. And there would be some other controllers based on what your use case is, right? Like event controller and whatnot. But so you could theoretically have like student repository and a event repository, and essentially just have each controller method directly interfacing with, that. One of the problems that happens is like where your application logic becomes more complicated. You can imagine a case where you have to do a bunch of validations and you have to like check if the student belongs to some event and blah blah blah, and your student controller, for example, gets too large. In that case, you'd naturally be inclined to like create a class in between that. And usually by convention, we name that as a service class. So instead of the student controller being like a whole bloated thing, you put that into student service. And instead of the student controller directly interfacing with the student repository, it will simply call a method in student service. And same with the event controller, we often don't want to interface directly with the repository. And instead have an indirect layer in between it. And this way, for example, when you're retrieving a student, you might want to do some kind of exception handlings, right? Like for example, if you are wanting to retrieve a student with like, let's say, get students ID, and you want to fetch a student with an ID of something. And right, so then it will call out to, student repository, and sometimes it will return it, sometimes it won't return it. But what if you wanted the failure to fetch a student as an exception? So you want that exception to be thrown. Now, imagine if you didn't have the student service in between and you basically had the student controller interfacing directly with the student repository. Then every time you retrieve a student with certain ID, or any controller that requires some kind of fetching of a specific student, and imagine they're like different types of operations, then you have to write error handling for all of them. But instead of that, you can have the student service as a layer and provide this method called getStudent, and get student by ID or email, whatnot, but have all the validation centralized. Same with like saving a student and like having a common validation logic at every cut point. So anyways, the waffle was too long, but the essence of what I was trying to say was that when you have an intermediary layer, you can bypass the need to duplicate a lot of code. And that's the reason why we prefer this kind of architecture, or organization of your files. And sometimes your student controller might even need some reference to the event service. And by having an intermediary layer here, you can already tell that doing this directly through the event repository would be slightly more messy because it's dealing with the raw data. But instead, if you have an intermediate layer, then it's a lot nicer in terms of like your interface. So all that said, I was meaning to get to this. So you usually have a controller, and we have service, and we have a repository. And of course we have a model, but you can tell that that's pretty obvious consequence of using a database. Let's go with that first. So how would I modify the current application to support that? I would create a services, and if you look at the student control, you can see that there's a student, create student, and you're passing a student data and you're saving it. So instead of directly calling the student repository, let's get rid of this. And instead, let's inject student service. Obviously, I still haven't defined what that is. So let's create a class student service. And under here, I provide a annotation called service. I'll get to what they really do in Spring application. And then I can do an import, and then save student data. And what I usually like to do is to just create a method without actually creating a method implementation in the service class. And I can do option enter on Mac, and it will say create a method. And so now we have the student service talking directly to the student repository. And we can save a student like that. And similarly, we can do a student service, save student, not save student, get all students. And yeah, I guess one of the benefits is that you can name the method in whatever naming you would prefer. And oftentimes you don't want to be directly using the naming pattern that the repository provides, just because it makes more sense when you're thinking about a domain. So you have a student service, returning that and saving student like that. Cool, let's run the application. Start it, and 8080 and students. Yeah, I think if we do a get, there should be some available. Student is a student. Yeah, nice. Let's post maybe one more, like cool. And if I do a get, I get 2 results. So in this case, we want to, I'm just trying to remember what I was trying to do. I have a memory of goldfish. So we have a student service. Right, yeah. let's go back to this part. So this weird annotation, like what exactly is this and how do they work? There are few concepts, like key concepts that you would have to remember, which is bean and singleton and spring container. And components. So what are they? They're basically referring to the same thing in Spring. I'm not sure if you've heard about Singleton at all, but I think the good place to start is like how many instances of student service is generated in Spring. Like if you run the application, how many objects of this class do you think exists at the runtime? So when I say runtime, I mean when I run the application. And the answer is 1, because this class is a component. This class is a bean. This class is a singleton. So they mean the same thing. What does it mean? It means they're defined to have only one object created out of them. How do you actually enforce that? That is enforced through an annotation. So this annotation is actually functional. And when I say functional, I mean it's not just a random string that you just put up at the top of your file. When you put that up, it allows Spring to understand that you want only one instance to be created for that class, and you want it to be managed by Spring, or to be precise, Spring container. But let's not use the word container because it might be confusing. I'll just say that Spring manages these beans or components or singleton. One thing that you might find interesting is that if you do a command click on that interface, no, sorry, not interface, annotation, you will see that there's an add component. And what that means is it's a component or a bean or a singleton. It's telling the Spring to make one instance of that object. So literally, what happens at the runtime is that this in the main, it's not shown here, but this will basically do something like this. So student service is equal to new student service. And similarly with the student repository, actually this is a way to indicate that you want one instance to be generated out of them. So if you look at it, you will see that there's a component annotation here as well. So student repository, new student repository, oops. And you know that there is no actual implementation that you have actually supplied, right? But because it's extending Mongo repository, the Spring framework, actually specifically the JPA framework or the MongoDB Spring Data framework, will know what kind of implementation to generate. So this will more likely look like, student repository info or something like that. But that object or the class definition is applied by Spring. And same with student controller. So if you look at the student controller, you can see that there is a REST controller, and if you go into it, you can see there's a controller, and if you go into it, there's components. So essentially, the bottom line here is that even though these have like different namings, they are all beans, they're all components, they're all singletons. And that just means that Spring is able to generate, Spring will generate instances for them, and then where it's needed, it will be able to inject it into places that it's needed. So controller, student controller, and new student controller. Right. And one strange thing is that, where does the wiring of, for example, this student repository happen? That's the interesting part, actually. So what this is saying is that when you create a student service class, an object out of the student service class, please give me an instance of student repository. And this specifically needs to also be a bean. And when I say bean, it needs to have a add component on that class as well. And sure enough, it does, right? Because it has a repository annotation, which has component annotation. And logically, because every AutoWire components are beans or classes that have object generated, that means Spring will be able to know exactly which object to AutoWire to the class that is demanding AutoWire. So for example, if I go back to here, you see that the student service obviously requires, you know, because I didn't make this into a public field. So it requires a student repository, but instead of creating one for this one specifically, it would have generated that object prior, and then it would try to inject that object into the field. So by doing so, you're enforcing that there's only single object out of each classes that has a singleton annotation or component annotation. Same with the student controller. It will pretty much do like student service, and I'll just make it public so that it can pick it up. Yeah, so this is what will happen at the runtime. And you know, all those dependency trees, because you need the student repository to have been instantiated before student service is able to use it. And for student service to be used, so for student controller to be constructed, you need a student service to be constructed. So that kind of dependency trees are constructed from Spring, because it's able to scan basically all the components that are defined within your application, and it knows what kind of thing or which class depends on which one, and it will try to construct everything from the leaf towards the root. So why is this thing, I guess, like useful? Like, why do we even bother, right? Actually, before that, one thing to note is that Spring allows no circular dependency. So what I mean by that is a student service requires this student repository, but student repository cannot require a student service. And that's enforced at the compile time. So that means, at the kind of a compile time, because it will throw an error when you try to run it. So in that case, like you wouldn't be able to even start the application. But that makes sense, right? Because if A requires B and B requires A, which one do you construct first? Actually, there's a way, but it's usually not recommended. Yeah, so why do we even bother actually? We bother because one, because it enforces that only one object is generated for each class. Otherwise, you get into very nasty problems of memory leaks. And when I say memory leak, I don't mean like security things. I mean things like unclean objects. Because every time you generate an object, that's a memory increase in your runtime application. And as your application gets more bloated, as you create more objects, like that's going to result in a poor performance application. And a secondary reason, actually, this one is also a pretty critical reason, is because of the concurrency. Because if you try to have multiple different objects created for one class, and you're depending on different instances of an object, instances of a class, then you're seeing a different version of that class. And sometimes if you depend on state, then it's not necessarily going to be accurate, because one object can have a different value to the other object. So those are pretty much like the two reasons I can think of from the top of my head. But it's also a good way to enforce like dependency injection, because you don't have to actually declare a object, and it allows you to create an interface beans, which isn't something that you have to understand now, but it matters as you develop more enterprise-grade applications. Now, is that all I wanted to cover? So, yeah, so that pretty much covers a lot of the stuff about, what has been and how does the auto wire work? What do these annotations mean? Repository, service, and controller. This one's not really a component. Like you are not gonna create a singleton of student anyways. You'll always have multiple objects. This is more for you to be able to specify which collection do you want to store your object into. So yeah, hope this video was helpful. Let me know if you have more questions. Otherwise, see you in the next video.